In the last chapter, we found out how we could basically create our loft surface. Select a path, click on the loft button, it creates a proto surface. We add some shapes to that surface, and lo and behold, we have a loft. What we're going to look at in this chapter are two of the rollouts which actually define the loft surface in a little bit more detail. We're going to be looking at surface parameters, and that basically defines, well, you can actually see it here. It defines smoothing, mapping, materials, and the output of the surface. The output is very simple, is it a patch or a mesh? But we'll just run through these in order so you get an idea of what I'm talking about here. Now, this DVD is recorded in 16-bit color, and that means that you will actually see some color banding here. So the smoothing that I'm talking about isn't necessarily going to be that obvious, but hopefully if I just turn this off here, you can actually get a better idea of what I'm talking about. You can see that the smoothing along the length of the loft can be turned off simply by turning this checkbox here on and off. And the other option is to smooth along the width. In other words, along this direction, along these segments of the surfaces. So if we turn this on, you can kind of see this here. You can actually see it smoothing here. If we turn off, it's actually not smoothing across these faces. So we get these kind of weird artifacts here. We can actually see the individual polygons. Now, this may not be that obvious, so let me just try and make some modifications to some of these stars here. I believe this star is actually used. So what I'm going to do is I'm going to go in and I'm going to put an edit spline modifier on here. And I'm just going to select these points and I'm going to say smooth. And then I'm going to say Bezier and just leave it like that. If we have a look here now, you can see because it's a dynamic relationship, it's updated our loft. And you can see now you've got more of a sort of curved surface here. So you can actually see the smoothing not being used in this dimension a little bit better now. So now if we turn these back on, you can see you get a much nicer looking result. So you can see most of the time you'll probably want these two tick boxes left on, but in certain circumstances you may not actually want the smoothing. So the option is always there. And the next options in mapping, as you can imagine, are to do with the actual UV mapping of the object. And if you don't understand this topic, I'd recommend that you check out our DVD on mapping fundamentals, which covers basically the fundamentals of mapping materials, 3D materials, and also 2D bitmaps onto surfaces. And it's explained in quite a lot of detail there. And we actually use the loft as one of the examples because it's actually quite a complex surface to put bitmaps onto. But I'll just show you what happens here if we apply a bitmap to the surface. I just need to turn mapping on here. Actually, let me just show you the bitmap. You can see it's this actual thing that you can see here. And if we view the image, I'll just bring it on screen. This is just what I would call a utility material, and it's basically designed to show you the orientation of a surface. You can see it's got some color gradients, red in this corner, purple up here, cyan green over here, and yellow over here. And we've got this kind of pivot point in the middle here. So when you look at the surface, you can see quite clearly where we have these gradients going along the surface. And you can see that if you look around the surface, at this point here, we have a seam. Can you see that seam? That's where the map basically wraps all the way around the surface from yellow, all the way around to red, and then stops. So that it basically goes around the surface once. And if we look down here, we've got orange. You can see it says U here. And then this stretches all the way along the length of the loft, all the way to up here. So you can see we've got 1 here, and we've got 0 down the bottom here. You see that? 0 there, and 1 at the top. And you can also see we've got 1 here, and we've got 1 here. That shows us that the material is basically repeating once along the length of the loft, and also once along the, as it were, the diameter around the circumference of the loft. So we can control these values by, well, we can turn off mapping altogether if we untick here, apply mapping. But as we've got a material already applied, we can't actually do that now. But what we can also do is we can say length repeat is 0.5, so it only repeats half along the length. So basically this goes from the bottom of the bitmap to halfway up the bitmap. Or we could say 0.1, which goes from the bottom of the bitmap to only 10% of the entire height of the bitmap. Or we can actually repeat more than once, and that will actually cause the bitmap to tile vertically. We can imagine this is the vertical axis. We can say once, or we can say more than once. We can actually scroll this interactively, as you can see. So if we do it twice, we get a repeat. You can see at this point it repeats and tiles. And let's say we did it 4 times, you'd have 4 repetitions along the height. And you can do the same thing, obviously, for this direction, going around here, around, as it were, the cylinder. We call this the U direction. So U, as if you can imagine, is left to right. V is vertical, up and down. So V maps along here, and U maps around the cylinder. So again, we can say 0.5, so it only goes around half the bitmap. 0.1, so it only actually uses 10% of the bitmap. That gets stretched around the cylinder. We could tile it, obviously. We could go up to 1, and then we could tile it more than once. You can have it repeat. And we got a 5-pointed star, so if we basically wanted it to repeat over each one, I think we'd have to use, what would it be, 10, I think, or 5? Let's try 5. And you can see that the bitmap starts here, goes all the way around to there, and I think it repeats then, does it? Yeah, you can see it actually repeats over every star. So if we say 10, now you can see it actually repeats twice. We've got the bitmap going once from here to here, and also again from here to here. So that's one repeat, another repeat, one repeat, another repeat. And we can do this in both dimensions. We can have it repeat in U and V at the same time if we need to with our bitmap, as you can see. The normalize button is a little bit esoteric, but basically what it means is that when we have it turned on, it treats the entire length of a surface as basically being uniform. And what I mean by that is that where you actually have these control points, where you've got these shapes, they don't influence the percentages. But when you turn it off, they do. And that means that, as an example, if you have a shape in the middle, and a shape here and a shape here, and you bunch this together, this will actually compress the UVs between here and here. So let me just turn this off. You can actually see this in action. So what I'll do now is, probably the best thing to do is just have this to repeat, say, twice. Actually, no, let's go for 4 times. And around, we'll just go for once. This is just a little bit clearer to look at. And you can see we've got a repeat here, and we've got a repeat here. If I turn on normalize, you'll notice that these repeats are where you would expect them to be. There's one repeat halfway along, there's one repeat 3/4, and there's one repeat at basically a quarter here. Now, if we turn normalize off, you can see that this repeat is actually bunched up and is closer to here and the same here. And also, if we go in and we modify these shapes, we just select one of these shapes and move it, you should find, well, we can't actually see this interactively, but you should find that this actually moves. So there you are, you can see it's getting pushed down towards here. And as it gets closer, it's scrunched up completely between here and here. So the UVs are actually kind of pinned, as it were, by the shapes. If I go out of sub-object mode and I just turn on normalize, you can see this pops back up here. And now the positioning of the shapes doesn't actually have any effect on the UVs. Generally, this will probably be the best option for you, having normalize turned on, which is why it's the default. But under certain circumstances, you may actually want the UVs to be based on the positioning of the shapes. So let me just go in here and put this back where it was, so it's a little bit neater. We'll just put it to 75% and come out of here. And the last 2 options, we'll just go through these very quickly so we don't get bogged down in this chapter. But basically, does the surface generate material IDs? And that will mean that we have a different material ID on the end to the main part of the mesh, and a different material on the end here. If there are material IDs built into the actual shapes themselves, if we define different material IDs for each segment of the shape, those material IDs will be inherited on the surface if we have this tick box turned on. And we already know how that works. I demonstrated it to you in the extrude tool and also in the loft tool. So we know how these particular options work. And then the last option is, do you want the surface to be output as a mesh or as a patch? You can see there we are. We'll turn on patch surface. And now we would actually be based on patches, which is As you can see here, it's actually based on Bezier patches, or it'll be a mesh with tessellation and subdivisions along its length. Let's move on now to the skin parameters. Let's whiz through these options here. First of all, do we cap the start of the object? And do we cap the end? Very similar to what we saw with the extrude and the lathe tools. You can have those on or off as needed. Then we have what kind of geometry do we create? Do we create morph happy geometry? In other words, geometry which is good for producing morph targets. As I said earlier on in this DVD, very often you'll not be creating lofts that will be used with morphs. So you may find in certain circumstances you get better results out of using grids for the geometry at the end of your surfaces. It just depends on the circumstance. Actually, let's have a look at the differences between those two. We'll just put an edit mesh modifier on here. And if we go into here, we'll just turn on wireframe. There's the end surface, and that's using, I believe, grid. Yeah, and if we change it to morph and go in here, edit mesh, we can't actually see the end faces here, so let me just select this. Now you can actually see the end faces. So you can see that the faces on the end are based on the subdivisions along the shape itself when we've got morph turned on. But when we go to here and we turn on grid, you can see what it actually does is it creates a kind of grid pattern and then kind of cuts out that shape in a kind of cookie cutter out of that surface. And so this is very dense. Obviously, you can see it has a lot of polygons in. But that density will also mean that it'll deform a lot better if you put some kind of modifier on there. And it may also render a lot better when you render it with those deformations. The long, thin faces in the morph version of the geometry may actually cause some nasty looking artifacts if you deform the surface. So there you go. That's a pretty good illustration of the difference between the morph and grid options. As you can imagine, the morph option is a little bit lighter, doesn't use quite as many polygons. So if you're not going to deform the end surface of the object, then you may want to just use the morph option. So the next options are that we can optimize the shapes so that if we basically have any straight segments, it'll optimize those. So we can just turn that on and see that here. You can see that it works in this segment of the loft up until this point here, but from here on it doesn't really work anymore. And that's because obviously all the way up to here we've got some curved segments. So it's got to interpolate between those two shapes. So basically there is some curvature here. But you can see as the curvature starts to die out when it reaches towards the shape, you can see the tessellation reduces. So there is actually some optimization taking place there, as you can see. So a pretty useful feature. For the next option, you can see it's actually grayed out here. And the reason for that is we actually have to change to a different mode for the loft system. So what I'll do is, rather than modifying this one, I'll actually shift copy it to here. And I'll turn off optimize shapes. So the option that I'm talking about is this option here, path steps. And it's a completely different mode to the way that the loft tool actually works. So if I change path steps to say 5, and now if I change to path steps mode, you can see that 3ds Max gives you a warning. And what that warning says is that when you're changing to path steps mode, it can only actually place the shapes on those steps. So we'll just say yes. And you can see it reconfigures the object, as you can see. And you basically have 5 steps. So you've got 1, 2, 3, 4, 5 between here and here. And you've got another 5 here. If there's a shape halfway along here, it has to be on one of these subdivisions, one of these steps. If you change the number of steps, it's going to redefine the object again. And when it does so, it has to replace these paths. And that means that when you're using the loft in path steps mode, it has a certain limitation in that if you want to modify the object in a dynamic way, these shapes will pop between these points along the path. And it can cause the surface to produce strange results. As an example, you could actually have 2 shapes that snap to the same point along the actual path, and that isn't really desirable. So I find I generally I don't really use it as an option. Anyway, we'll just say yes. And but what it does allow you to do is it allows you to use this optimized path button here. And again, optimizing the path may significantly relocate the shape. So we'll say yes. And in this case, it's not really going to have much of an effect. And that's because the path doesn't really have any straight sections in it that optimize very well. But if it did, these areas would have less steps along them and they would be tessellated less. Obviously, because they have less steps in them, that means that the positioning of the shapes along the length of the path would change. And that was what that last warning was just about. So it has quite a lot of caveats, which mean that generally I don't really use it as the mode when I'm working with Loft. It's got too many limitations with it. So with that being said, let's just delete it and go back to this object here, which is not using path steps. I'll turn off optimize shapes again. We'll just put down the number of steps in the shapes a little bit so we can see things a little bit more clearly. And the next option we have is adaptive path steps. So if I turn that off, you can see what I have now is basically explicit control over how many steps we have between each point here. But it isn't necessarily the best option because with adaptive steps, what it'll try and do is actually put in enough steps in any one area of the loft surface to achieve a nice surface at that point. So generally adaptive steps is the option that you'll want to be using. Under some circumstances though, obviously that will cause the surface to change its topology if you change the curvature, and that may cause issues if you've got any kind of modifier stack above the loft. So in certain circumstances, you won't want it to be adaptive. You'll want it to be explicitly defined by the steps value here. So you can use that option depending on the circumstance that you find yourself in. Now, for the next few options, it might make more sense if I actually recreate a different loft here. So let me just move this over here. And what I'm going to do now is I'm going to just create a rectangle. So we'll just create this here. And it's going to be pretty big and wide. And what I want to do now is just change the pivot point. We'll just put it here until it's right on the edge. Use the snap system if we wanted to, but I don't really need to be that precise here. Now what I'm going to do now is just select this here, go to compound objects, choose loft, and then get shape. Click on here. And I think with this shape, we'll find that when we look at these next few options, it might make a little bit more sense. So if we've got contour turned on, you can see that basically what that does is, if you look at the beginning of the shape here, you can see that the shape is basically perpendicular to the direction of the actual path. And if we turn off contour, you can see that it keeps that relationship. That angle never changes along the length of the path. That will mean that obviously you get the surface collapsing down to being almost zero at this point, and that's not really very desirable. So generally you'll want contour to turn on so that it basically always keeps the shape perpendicular to the path at the point that it's on, as you can see along there. So I hope that makes sense. The next option, banking, you can see when I turn it on and off, it doesn't really make any difference. So I believe for that to make a difference, we need to actually have some change in the path in this axis as well. So let me just go in here and change this path slightly. So just grab this point here, move it down here. There we go. You can see it's causing some crunching there. But anyway, obviously that's going to change this object as well because this path here has been used in both of these objects and it's got a dynamic relationship to both of them. So now if we turn banking on, you can see the difference that it makes, as you can see here. So basically what it does is it causes the shape to actually twist along the curvature of the path. So if we just turn on and off banking here, you can see that basically when we have banking off, it basically keeps straight vertically as it goes along here. But when we turn banking on, you can actually see that it actually twists slightly as it goes along here. And I believe that the stronger that this change in height is here, the more banking that you'll actually see. So as an example, if we grab this and put this down here, You can see now that we have probably more banking going on. Let's just click on here and turn it off again. You can see that more clearly now. It kind of keeps this straight relationship, but if we turn on banking, we get this twisting going on. So you may find in certain circumstances that you need to turn banking on or off, depending on what you want. The default is on. So obviously under most circumstances, you'll probably find that having banking on is something which is desirable for your particular object. So let's just put some curvature back in here. You can actually see one of the issues you've got here now is that the geometry sort of crashes into itself. So this is something you'll have to deal with when you're modeling a loft. You want to kind of avoid stuff like that. It's pretty ugly, really. But anyway, I think it gives you a pretty good idea there of how banking works. And then we have constant cross-section. And what this does is, under certain circumstances, what you'll find is that when your loft goes through a very sharp changing in angle, usually 90 degrees, you'll find that if there's a shape placed at that point, it'll be at, say, 45 degrees to the other splines, the other spline shapes. And you'll find that, I don't know if you've ever noticed this in geometry, but if you rotate something through 45 degrees, it loses width. And that can make the tube appear to actually taper in towards that point. And that generally isn't desirable. If you're creating, let's say, a picture frame or a piece of square tubing, you want that square tubing to keep its thickness when it goes into the corners. So to do that, Autodesk added this option, constant cross-section, and that basically scales the shape wherever you have that kind of rotation and ensures that the cross-section at that point is constant, and you get a nice constant thickness to your tubing or your picture frame or your coving or whatever it is that you're looking at. The next option, linear interpolation, it's not really going to make much of a difference on this object, but you may actually see it on here. If we look here, you can see that this profile is quite a bit bigger than this profile here and this cross-section. So if we make that more marked, if we just reduce the radius of this even further and really scrunch this down, so we get really tiny in the middle point here. If you look at the difference between the two cross sections, you'll see that it interpolates between the two in a very curvilinear manner, which is very pleasing. But you may find in some circumstances you don't want that, and you want the interpolation to be linear. So you can see now that we basically have a linear change in the size as it goes from one shape to another, as you can see here. And then we have the change here. But I think you'll agree most of the time you're probably going to want to keep the linear interpolation off so you get this nice spread curve as we get the change in the profile sizes. As I said, in some circumstances, you're going to want a linear relationship between those, so you can turn that on and off as needed. The next option, flip normals, that's going to change the surface direction. So now, as you can see, it's inside out. You may find under some circumstances, let's say you actually loft an open shape, then you may find that the surface direction is actually wrong and you get this result. It'll actually be inside out. When you find that circumstance, it's very easy to fix because all you need to do is turn on flip normals and it will then change the surface direction to be correct. If it's a closed surface, a closed shape, you'll find that it pretty much always has the surface direction in the right orientation and the polygon's normals are facing outwards. So you'll need to use this rarely, really. But as I said, it'll come into its own when you have open shapes being lofted. Something that you'll notice is if you look along the loft, you can see that all the polygons are basically defined as being quads. It's actually an edit mesh surface, so underneath it's actually made up of triangles, but it tries to keep all of basically the surface is made up of quad polygons. If you turn this off, it doesn't bother doing that, and it actually will make the surfaces up out of tris. The reason why this option is here is because if you convert the surface into an edit mesh and you have quad sides turned on, it's really not going to make any difference because at the end of the day, it'll convert all of these into tri-meshes anyway. But if you were to convert the surface into a poly by using the tool here, edit poly, or if you were to put an edit poly modifier on here, then the edit poly would actually keep those faces as being true quad polygons. So it actually makes quite a big difference to the end topology. If you turned off quad size and converted to an edit poly can support triangular faces, quad faces, 5-sided, 6-sided, whatever. So it would actually be able to represent the surface with triangles, but you may find that you probably want to keep it as quads. So this option is on by default, and you probably want to keep that on as well. The next option, transform degrade, is a kind of hangover from the old days, really, where machines weren't as fast as they are today. I find that you generally really don't need it these days. What it does is it basically turns off the surface updating when you make a modification to the shapes or the path. As we saw earlier in this chapter, it's not really that useful anymore because it stops you seeing what's going on. What I mean by that is, I believe it only actually has an effect when you make modifications to the subshapes. So let's try doing that. Let's see what happens when we do so. Let's select that and try changing it. Yeah, you can see now that we can actually see that in real time. Let's try coming out here and turn on transform degrade and go back in here. And let's try that again. Yeah, and now you can see it actually hides the surface. You can see that if we change that shape in any way, we can also scale that shape. This thing you can do as well. And let's see if we can actually transform it. Yeah, you can transform it as well. So you can see you can do some pretty groovy stuff there. But you can't actually see that in real time. But obviously, if we have transform degrade turned off, then we can. We can now see our modifications in real time. As you can see, we can now scale it. And we just see that in real time. We can also rotate the shape as well. So we can kind of skew the shape compared to the path at that point. Pretty neat stuff. But as I said, if you want to see that in real time, you need to turn off transform degrade. And the last two options that we can see here are skin and skin shaded. And what they allow you to do is, if we turn off skin shaded and skin, we can't see the skin at all because we've actually turned off the display of it. And if we go into wireframe mode and we do the same thing again, you can see you can't see it. But if I turn on skin and shaded, I can't see it now. But when I go into shaded mode, I can actually see it. You can see. So it's hidden in wireframe mode, but it's shown in shaded mode. Whereas if I turn on this option, it's shown in whatever mode. It doesn't really make any difference. So you got those options there. In certain circumstances, let's say you're working in wireframe and you just want to see the individual objects. Let's say, you know, we want to go in here and select these shapes. Now you can actually see these more clearly. And then when you go into shaded mode, you want to see the full surface. Well, those are the two options for you. As you can see, with these two, you can decide whether it displays the skin at all, in fact, actually, and you can have it so that when you're in shaded mode, it doesn't display either. This doesn't make any difference to rendering. If you actually click on render, you can see when you come to render time, it will still create the surface. It still exists, but it doesn't actually display in the viewport, depending on those options. So the surface is always there, but these are just basically display optimizations that may aid you in your modeling. So there we go. I think we've basically covered everything in skin parameters here and also in surface parameters. Quite a lot of ground to cover, really. And what we're going to do in the next chapter is we're going to look at a few more tools before we finish off with the loft tool. And they are the deformation tools that you can see in this rollout here. They only become available once you've actually created the object. When you're actually creating the object in the first place, they're not actually there. And I can show you what I mean by that. If we go here and we go down and we say loft, get shape, you can see that we haven't actually got the deformation rollout. Once you've created the object and you go to the modify panel, you can see that the deformations rollout becomes available and you can actually make your modifications. So let's move on now into the next chapter and we'll actually look at what those different deformations do.